Good morning, children. So in the last class, we have completed rational numbers. Today, moving on to the next chapter, squares and square root. Just we'll go with the introduction to it. So we all know about square, right? So square, you know, what is the area of a square? Side into side. That is nothing but length into length. And we know the formula also. So we are going to multiply a into a. We are multiplying same number. Right? So we have given side of the square is given here. And area of the square is 1 into 1, 1 or 1 square. So 2 into 2, 4, or you can write it as 2 square. Next 3 you have 3 into 3, 9, 3 square. 5 into 5, 25, 5 square. So like this so on. So if you have a side A, then area will be A into A square. Then what is special about these numbers? So these numbers like 4, 9, 25, 64. So you can express it as 2 into 2, 3 into 3. So here you can see here it's a product of the number with itself. It's a number, it's a product. These numbers are the product of the number with itself. Such numbers are called as what? Square numbers. Okay. So if you have a natural number m, it can be expressed as m into m or m square, or it is equal to n square, where n is also a natural number. So you can say m is a square number. M is a square number. Okay. So numbers we have, anyway you have to know, you should write the square numbers from 1 to 100 in your classwork, and highlight the squares of prime numbers, because composite numbers you can find the square root using factorization method, but prime numbers it is very difficult to find out. You should know the squares of prime numbers. Now we will discuss. So the square numbers are also called as perfect squares. What we can call? They are called as what? Square numbers are called as perfect squares. Now we'll move into the different properties of square numbers. So you know 1 is an odd number, 2 is an even number. So just you can see here, square of an odd number is odd. Square of an even number is even. So 2 2s are 4. 12 12s are 144. 1 into 1, 1. It's odd number. 11 into 11, 121. It's odd. Okay. So what you can say? And square of an odd number is always odd. Square of an even number is always even. And just check for the digits in the unit place of a square number. Okay. So 1 means you have 1. 2 means you'll have 4, 3 means 9, 4 means 6, 5 means 5, 6 means 6, 7 means 9, 8 means 4, 9 means 1, 0 means 0. So you can see the unit digit here, 1, 4, 9, 6, 5. So 6, 9, 4, 1, 0. So you can see here the perfect square numbers end with either 0, 1, 4, 5, 6 or 9. Okay. If it is a perfect square, then those numbers will end with 0, 1, 4, 5, 6 or 9. If it is a perfect square. And numbers ending with these need not be a square number. So other numbers also can end with these. But a perfect squares always end with either 0, 1, 4, 5, 6 or 9. Okay, by looking at these digits, we can identify the perfect square numbers. Okay, and so 50 they have given up to 50. Hopefully this table you note down in your classwork. It will be helpful. Okay, and if you can see here, if you have 1, Okay, if you have 1, then its square ends with 1. If you have 9, then its square ends with 1. So if you have 199 in the unit digit, then its square ends with 1. Its square ends with 1. Okay, and if you have 2 and 8, then its squares ends with 4. If you have a number in the unit place 3 and 7, then its square number ends with 9. If you have 5, then the square number ends with 5. Okay, you should remember this. If you know this, it will be helpful in solving the problems, especially division method. Okay. And some more interesting patterns you have adding triangular numbers. So 1. If you add 2 to this, you'll have 3. Okay, if you add 3 more, you'll get 6. If you add 4 more to this, you'll get 10. If you add 5 more to this, then you'll get 15. So you can form a triangle. So these numbers 1, 3, 6, 10, 15 are called as triangular numbers. It is called as what? Triangular numbers. Okay, so here it is a square here. 3 plus 1, 4. Okay, 3 plus 6, 9. Here, 6 plus 10, you'll get 16. Okay, you can combine. If you combine so much for this triangle, if you add 1, you'll get a perfect square. If you add 3 more to this, you'll get a perfect square. And if you add 6 more to this, then you'll get a perfect square. Okay? So next, how many perfect squares are there between two numbers? Between two square numbers, how many numbers you will get it? So if you have 1 square, between 1 square you will have only 1. Between 4, how many numbers will get? 2 and 3. 2 and 3. 3 square means how much? 3 and 4. When 2 and 3 means 5, 6, 7, 8. You'll get 4 numbers. That is 4 non-square numbers you can get. Okay. Next, 4 square and 3 square. Between 3 square and 4 square means you'll have 1, 2, 3, 4, 5, 6 you will get. How many numbers you'll get? 6 non-square numbers you will get. In the same way, between 4 and 5, between 4 square and 5 square, how many you will get? 2, 4, 6, 8 you will get. Okay, you have a pattern here. So now 1 square means 1, 2 square means you'll have 4. Okay, 2 square means there are 2 non-square numbers. Between 2 and 3, there are how many? 4, 2 into 2. The same with the pattern goes on. So you can write here how many. So you can generalize it. So in general, we can say that there are 2n non-perfect square numbers between the squares of the numbers n and n plus 1. Okay. So in general, what you can say? There are 2n non-perfect square numbers between the squares of n and n plus 1. So if I take n is 1, n plus 2 will be 2. So between 1 and 2, you don't have any 2n. 2 into 1, 2 numbers, like that, non-perfect squares. Okay, 1 means here 1, 2 means 2 square 4. Between 1 and 4, which are the numbers you get? 2 and 3, which is non-perfect square. Okay, so you'll get 2 into n. So you can take this n and multiply with this 2. So many numbers, you will get it. So you will understand these concepts while solving the problems. Next, adding odd numbers. Adding odd numbers means you can find the squares by adding the odd numbers easily. So if you have one odd number, it is 1 square. If you have 2, then Sum of these two is 4. That is nothing but square of the, that is nothing but 2 square. Okay, if you have 3, so 3 means sum will be 9. That means 9 is nothing but 3 square. How many odd numbers are there? There are 3 odd numbers. So it is 3 square, 9. So you have 4 odd numbers here. 4 square, 16. So directly you can find the sum. If you know then how many numbers are there, add, now just count the numbers 1, 2, 3, 4. What is the sum of this? 4 square. It will be 16. You need not sit and add. Directly you can find the, just count the number, find the square of it. That will be the sum of odd numbers. So you can say that sum of first n odd natural numbers is n square. Sum of first n odd natural numbers is n square. N means you have to just count the numbers. Okay. Next, what do we have? Subtracting the odd numbers. We can find the perfect, perfect squares or square roots by using subtraction method. So, but we have to subtract what? We have to subtract odd numbers from the given number. So, if you have 25, 25 minus 1, 24. Next, 24 minus 3, 21. 21 minus 5, 16. 16 minus 7, 9. 9 minus 9, 0. So, what is the square root of 25? Count the numbers. 1, steps you just count it out. 1, 2, 3, 4, 5. So, square root of it is 5. So, 1, 3, 5, 7, 9. If you add this, you will get 25. So, how many numbers are there? 5. So, square root of this 25 is 5. So, successive subtraction method also you can find. Okay. So, if a natural number cannot be expressed as sum of successive odd natural numbers starting with 1, then it is not a perfect square. It is not a perfect square. Remember this. Okay. Then sum of consecutive natural numbers. Sum of consecutive natural numbers usually, what do you take? N square plus divided by 2. This is the general form. Okay. So, as we solve the exercise, you will come to know. Next. Product of two consecutive even or odd natural numbers. Product of two consecutive even or odd natural numbers. So 11 into 13, 143. How do you find out? In between, you have even number 12. Just square that number and minus 1. You will get the sum. You will get the product. You will get the product. You need not worry at all. Okay. So 12 square means you have learned the identities a square minus b square. Okay, using that also you can do it, or directly you can do with this also. You will get it. So generally we can say that a plus 1 into a minus 1 is equal to a square minus 1. Okay, a square minus 1. That's it. No problem at all. It is very, very easy. Next, some important patterns in square numbers. So you have 1. 1 means 1. 11 square is 1, 2, 1. 1, 1, 1 square is 1, 2, 3, 2, 1. So you'll get a very beautiful pattern. You will get it. So in the form of a triangle. In the form of a triangle. Okay. Here another interesting pattern is 7 square, 49. 67, 4, 4, 8, 9. 6, 6, 7 square, 4, 4, 8, 9. So you can see the beautiful pattern here. So you can try these numbers with other numbers also. You'll get very beautiful patterns. Okay, patterns for square numbers. So this is about just an introduction. This is just an introduction. So here just we will discuss. Okay, we'll just discuss the exercise. You'll get an idea. So what will be the unit digit of the squares of the following numbers? So I'll be discussing only first three mains. These first three mains you note down in your classwork. Okay, I've discussed. I'll send the picture of this first three mains. You have to write it in the classwork. Okay, I'm not sending any PDF for this. Listen, understand, then write in your classwork. Okay. So if you have 1 here, you have in the unit digit 1, then square of this number, then end with 1 itself. If you have 2, it will end with 4. So here you have 9, 9 9s are 81, then your first square number will end with 1. You have 3 here, 3 3s are 9, so ends with 9. Just you have to mention. Here 81 you write, unit digit will be 1. Here 2 is there, 272, hyphen, you write 4, like 4. You have 9, hyphen, 1. 3 you have 9. 4 you have, 4 means 6, 7 means 9, 8 means 4, 0 means 0 itself, 6 means 6, 5 means 5. Just you have to mention the number, that's all. Okay? Now, the following numbers are obviously not perfect square. Give reason. So here, number is ending with 7. So it is not a perfect square. Here, number is ending with 3. That is why it is not a perfect square. So all the numbers you write, final conclusion you can write. What you can write? Then perfect square numbers always ends with either 0, 1, 4, 5, 6 or 9. Final conclusion you can write it. So but you have, there is a special property with the zeros. You have here 3 zeros. So if it is a perfect square, the number of zeros should be multiples of 2. Then only it will be a perfect square. If it has odd number of zeros, then it is not a perfect square. It should have even zeros, even number of zeros. Okay? Got it? Next, the square of which of the following would be odd numbers? So if you have odd number in the unit digit, then such number will have odd numbers when you square it. So first number is what? 431. So 431 has 1 in its unit digit. Therefore, its square also ends with odd number. So here you have 9. So only these two numbers, 431 and 7779. So these two numbers have odd numbers in the unit digit. Therefore, these two numbers end with odd number itself. Okay, just you have to write only so much. Is it clear? Got it? So other part of the sums I'll be doing in the next class. Thank you. Hope you have understood this first 3 mains, what you're supposed to do. If you have not understood, rewind and listen once again. Okay? Just read the question clearly and write only the answer. That is one number. That's all you need to write for the first main. Second main, write all the numbers at once, list it out, and final conclusion you write as the perfect square numbers always ends with either 0, 1, 4, 5, 6 or 9. So in these numbers, in unit digits, the numbers are not ending with these numbers. Therefore, all these are not perfect squares. So last number, if you have odd numbers in the unit digit, then such numbers squares will also end with odd number itself. Okay, hope it's clear. Thank you.